Welcome to Lab 5, the Choose Your Own Adventure Lab. For this lab, I chose to predict the motion of a cliff jumper. The person jumped directly off of a cliff into the water with nothing attached to his body. The objective of this lab was to observe the motion of a person that falls straight down and compare models based on Newton's second law that included drag in one of them and only included the weight force of gravity in the other one. I captured the video of the motion and analyzed the video and tracker to get the position of the person. I then constructed computational models to display this. Using Newton's second law, we can see that the model predicts farther motion when only taking into account the effect of gravity. When we add in the effect of drag, the expected motion matches the observed motion. For this lab, I got a video off of the internet and imported it into Tracker. I used the Tracker to spot the positions of the person as he jumped off of the cliff into the water as shown here. For this, I had to estimate the average height and weight so that I could use the calibration stick. I used the average height and weight of a man for this. I tracked all of the positions in the y direction. I then went to Python to create a computational model. In Python, I inserted all of the information, including the mass, which I estimated to be the average mass of a man, and the initial position and velocity vectors. I then continued down to estimate the time that was calculated. Here we can see that there is a drag force constant that is inserted. This is used for the second graph. We can also see that the net force includes the weight plus the force of the drag. In the first model that I will show, I had the B set to 0 and the net force only equal to the weight force, which is the negative weight of the person, negative mass of the person, times the gravity force in that direction. When we run this model, we can see that the model shows the person going in the negative direction. This is very accurate. We can also see here that over the period of a little bit less about 0.75 seconds, he travels down around 3 meters. This is pretty accurate, given the video that we tracked. We took the information that we were given through the tracker positions and through the positions that we modeled through our Python model. I put it into a CSV file using the time, the experiment data, and the model data. Here we can see that the experiment data shows the jumper going not quite as far as the model data shows. This is because this graph shows the position of the person going with only using the force of gravity. The second graph here is the one that is found using the model data, the experiment data, and the new model data when we factor in the drag force. We can see that here at the end, the model with the drag force, which is the yellow line here, matches up with the experiment data. This proves that Newton's second law holds true because adding the two forces is a better representation of the actual data. You can see that there are some discrepancies among the lines here. This is caused by user error when plotting the position in Tracker. This model is different than the labs that we have done because it starts above the axis. This is because when I set the axis on Tracker, the person started above the origin. You can see that there are slight discrepancies in this graph as well, which correlates to the graphs that we found in the CSV file. In Tracker, I decided to start the position where I did because it was the point at which he was moving in the downward direction. At the very beginning of the video, he jumps up first and then travels downward, so I started the position when he was moving downwards. The drag force constant was found by guessing and checking to see when the Python test would end close to a value that we got from the experimental data. This can be shown. This is a reason why this point here matches on the bottom, because we changed the constant so that they would equal each other. Overall, we can see that Newton's second law holds true, that the model predicts further motion when it doesn't take into account all of the forces on the person. When we add in the force of the drag that's moving the opposite direction of the force of gravity, the expected motion matches up to the observed motion.